Hold on. One minute 56 seconds. Okay. Let me switch it up. All right. What did I get up to? So I skipped a day. Usually I do this one a day. I did that for 4 days straight. Next, yeah. So I skipped a day. I skipped yesterday, and then today. Between today and that last stream, I've been doing a lot. So specifically, what I finished you guys with is expressions and pattern matching, and I finished those, right? But I didn't really have. I don't know if I had even variables. I didn't know if I had variables, but I think I did. But right now I've just finished standardizing, like not even standardizing, just completing all the semantics with variables. So that all works now. What did I do? So here I added this add and fix. I've been doing all these things. I implemented mutable variables, the semantics with variables, the rules around defining extra variables, shadowing rules. What else did I do? Yeah, I did all of that. Didn't really do a whole lot. You know, no, I did the do block as well. I did the do block, so you can have multiple expressions on one line. I'll figure out what I did in between that. Let me open up Git. All right, here's the commit from that last stream. So I did parsing. I did so much. Parsing function call expressions. Parsing the do block. Parsing tuples. Yeah, and all the semantics to do with assigning variables. So that's 4 different things. That's 4 different things. So I'll go over them. I'll go over them one by one. Okay. Now I'll start with the semantics around variables. There you go. Let me zoom in real quick. Let me zoom in for you, everyone. Okay. So running this parses the file and generates this this module. So you can assign variables types using the dash this thing. That was possible with functions. So I just made them go on identifiers because that's how these things work. So these go to identifiers, and the first assignment of an immutable variable is its declaration. So this is defined here. This is an explicit assignment statement, explicit like decl statement. So this will just print out its name and it'll print out its index into the locals. So this is just it. And then you've seen function declaration. So k to g equals k plus v, and then it'll actually print the locals it resolved to. So k is local of index 2, and that's a function, and it matches on the variable g. And see how it says colon 1? That means it creates a new variable. So it creates a new variable inside the scope of this switch. And that goes to the it goes to add g plus 1. No, it just adds g to 1, like g1 and v0. So that's what this function does. And then here k is called with 20 because that's how function expressions work in this language. Languages like Haskell. So you can do a, b, c. That's equivalent to a, b, c. If you know like the curried representation of functions, that's essentially it. So I'm calling k with 20, and that ends up with it resolves to k2, and that's called with 20, right? And so this is variables. And then okay, I'll go over some more. I'll go over a more complex case of variables. I'll try and bring an example. Here's a good example. Okay, here we are. So this is a do that opens a new block. Don't worry. How this works. Yeah, how this works is that it continues parsing, so it gets the column of the first. So okay, when the parser reaches do, it goes to the next token, right? And then this next token has a column. So this column number would be 1, right? Because a tab counts as one character. It'll move on to the next token of the next line. If it equals the same amount of columns from the left, it'll continue parsing the do, right? And it opens up a new do. It'll go to the next token after the do. This is on column 2, right? Because there's 2 tab characters. It'll move on to the next next token after the line. There's two tab characters here, which means it's on column 2, right? But then it'll go to the next one, right? It'll go to the next one, and it can't consume any more statements because it's not on the right column of 2, and this can't consume any more statements because it's not on the right column of 1. So it breaks out of it. This is how these do blocks work, and I'll quickly show you how they work. Node do block. P-do, right? I'll go to where it's used. So this is the p-expo. You've seen this before. So this grabs the left-hand side and then recurses over the right-hand side. So on the left-hand side, if it comes across a token which is toc-do, it just returns p-do s, and this is currently a to-do right now. It currently it's not meant to be chained, so you can't do like a do block and then add the value of the do block on the right-hand side. So it just does a return. And how this works is currently in this position, you're at the do block here. And then it iterates to the next one, checks if it's an EOF, and then other than that, if it's an EOF, it just returns void. And yeah, so it expects a new line. So expected new line after do. And gets the current original column. The amount of ASCII, the amount of Unicode characters, or it's ASCII characters, the amount of bytes, basically. It's the amount of bytes from the left to the right. So that's the column stored. And so it constructs a new block, and while the token.kind is not an EOF, it keeps consuming statements until the current token column does not equal the column, the original column. And it breaks out of the loop, and then returns the values and everything. So that's how do blocks work. And what do blocks do is they create new scopes. You can see IR new scope parent s. So these things create new scopes. Yeah, so it calls p statement with block.doBlock.scope. This is a new scope. And so these are just to showcase 2 different types of variable declarations here. I remove one of them, so it's easier for you to you guys to understand. So here, actually, yeah, I'll do immutable variables first. Okay, so y equals 20 on the scope at the top level. IO main creates a new scope, and then y equals x. Now, these variables are always immutable if they're like this. So it is completely nonsensical to like redeclare a variable. That's not right. You can't do that. An immutable variable has one declaration. It's essentially a binding, a functional binding. So yeah, so a equals 20. There is no other instances of a equals 20 or a equals whatever in this scope. That's wrong. So, but what you can do, you can have another thing of this with this expression. You can have another one, only if it's in another scope, right? That means you can shadow this variable here. So you can shadow it, and it compiles fine. Yeah, so you can shadow this. This creates a completely new variable, and you can see in the output. That this here. You can see in the output that it says. Yeah. So this is y0, and this is y1, and this is the declaration, so it's type inferred. And then yeah, there's another declaration of x here. That's x2. So y0 is just its own thing. Y1 is what's used inside the function. And what you can do now, though, is you can do y equals y. And see how this is y0 out on the front. It creates a new variable y1 with the one of the same name. So it's just y0. So it shadows it. Essentially, it shadows it. And this is what's allowed. You're allowed to do this. But what you can't do is declare another one like this, right? Variable y exists in scope. Yeah, variable y exists in scope. And I want to create a better error message for that. So let me put this here. Yeah, y20, y30, better error. I want a better error message. Yeah, so variable y already exists in scope, but yes, so this isn't allowed. You can't do this. But what you would think you can do is you can do something like this. Here, let's say I swap around the order of these things. Yeah. Okay. So, I mean, this makes sense, right? You can look at this thing and it makes sense. Y references this, and Y is a new variable. But you're declaring a new variable in the same scope, but all the variables before it reference that. It seems like that's an easy way to, like, it's an easy way to, like, fuck things up, especially with everything. So what I do is I disallow it. I think other languages disallow it. Rust, I think you can shadow everything and anything. But in my language, I want this to be an explicit error. Why is this not an error? Why is this not an error? Fuck, it was an error. Let me... Hold on. This is bad. This should be an error. Hold on, let me show you. And I'll fix this later. I'll fix this after the stream. The fuck? Where do I fix it? Is it declare mutable variables? Better error messages for duplicate bars. Let me check out. There we are. Okay, so this is variable already exists in scope in this. So this is a different one. Where is it? I can't. Maybe this one has it. V equals 20. K equals V. Wow, is that not an error? Hold on. Hold on. That shouldn't be happening. Let me just migrate name to var and proc devil. Where is this? Oh no. Fuck. I fucking hate Git. Check out. Okay, fine. Just Git reset. Hold on. Why is that not an error? I just do this. Still not an error. Wow. I can't believe it. I thought this was fixed. Alright. Fucking hell. Yeah, anyway. What a joke. Okay, so just take my word for it. So this is a scope IO main do. You define the variable x and that uses y. But you define y in the same scope. This is not allowed. It'll raise an error and say y has been declared here, there's been uses before its declaration. You can't do this. You can't shadow a global variable but then use it before, right? You have to have it like this. There has to be explicit order. So if you define a variable in the same scope, if it has uses before that, that's an error. And it should be an error. It's annoying that it's not. Yeah. Okay, well, I got that out of the way. So there's do. Okay, I need to explain mutable variables as well. So this is a mutable variable. This would be called v prime, but it's not. I'm using like a prefix version. Anyway, these are mutable variables. Mutable variables in this language have an explicit like setting. They look different. They look completely different. You can tell what kind they are immediately by looking at them. So yeah, so the immutable counterpart would just be v, and the mutable version would just be dash v. And since these things are fundamentally different, immutable and mutable. So you can shadow like this, right? But this doesn't actually declare a variable anymore, because there's this ambiguity, right? If you're in here, are you trying to shadow v, or are you trying to reassign v? But from the parser's point of view, let's say from the parser's point of view, it can't resolve this statement. Like, okay, do we assign it or do we create it? From how I want to do things, the parser once the representation gets to the checker, all variables must be resolved. Everything must be resolved. In what order, in any order, that should be resolved. So I don't want to. I want to make sure it's explicitly. I just want to make sure mutable variables have explicit declarations, right? Because there's no ambiguity here if they're both immutable, right? You always know that v can't be changed, so you must think that v creates a new variable, but you don't know here. You don't know if you're creating a new one or you're setting it. So this is how you make it explicit. You use mut dash v equals 20. And you can see here, dash v, that's set, and then do, and then that's assigned. So this would usually be like plus or something, right? So this isn't an explicit assign. This isn't a declaration. It's an assignment. That's why it has this thing here. So dash v0 assigned to 30. But if it was an explicit declaration, it would be dash v0 20. It would have the type in there. So that's how it works. That's how mutable variables work. They have to be defined like this. They have to have some kind of something that would tell the parser that you're creating a new mutable variable. Because if it's an immutable variable, you can't change it. So you're always creating new ones. So that's how you explicitly tell the parser that yes, I want to make a new one. And you can shadow them as well like this. Yep. So this is v0 and v1, and that just breaks. There's like an implicit break of a void. So this do block returns void, returns unit type. So I explained mutable and immutable variables, do blocks, and now I need to explain function calls. So let's define a function a, and that takes x and y, and returns x plus y. Yeah. So what does that show? X0, y1 plus x0, y1, and I want to call a with 20 and 5. This is how it works. So I don't want to explain curried representation, because if you're here and you're learning about it, you probably would know it already, or you go on Wikipedia or something. Just go read like some Haskell documentation. Read the docs of Haskell. Anyway, how it works is that a is being called with 20. It evaluates to a function that takes in an integer and returns one. So you call that with 50. It's not a 20 and then it's not like this explicit thing like this. You are genuinely calling a with 20 and then you're calling it with 50. The return value of a called with 20 is compatible and can be called by 50, and that finishes. So that's how it works. A2 with 20 and 50, and you can add. So function calls have less precedence. They have like much less precedence than plus. So it'll call and call, and then this thing will be held entirely, and then it will add 30. But what you can do here is you can quote the 50 and 30. And here, and then this value, the 50 plus 30 evaluated, 80, it gets called with a. But if it's separate, it's a getting called with 20 and 50, and then that whole thing plus 30. So that's how this works, right? And I'll get into the ambiguity with function calls and unary expressions. So take a look at this. A is being called with minus 30, right? But you'd think it'd be called with minus 30, but no. It's a minus 30. It's a minus 30. In an imperative language, you'd usually see this syntax. Then it's very explicit, and you know exactly what's being called with the argument. But you don't. In a functional language, you don't. So the parser can only see it as a plus 30, and not a called with minus 30. A minus 30. Yeah. The parser either sees a minus 30 or a called with negative 30. And there's no, like, you would think that a is being called with negative 30, and that depends on white space. And I kind of want to do that. I want if it's like this, it should be parsed with a minus 30. If it's like this, it should be parsed with a being called with negative 30. That's what I want it to do. It doesn't work like this now. You currently have to put them in parens like that. But yeah, so and that follows with languages like Haskell, right? So there's no white space dependency. But in the future, I kind of want to make it that if there's no white space here, it's definitely negative 30. And the thing is, like, it's not just functional languages, right? Haskell has this problem. You have to quote them like this. OCaml has this problem, so it creates explicit unary, like a explicit. It doesn't do this. Like, it uses like negative tilde. Yeah, I wrote something about it here. Yeah, implemented Haskell like function calls. Yeah, makes sense in the degwad output, right? Binary expressions are shown to argument function calls. Yeah, calls have low precedence, but here unary fuck up. So p equals p called with negative 20, but that's not right. The original function is a binary expression with p minus 20. Yeah, so what about unary fuck up? This is a very common problem with special function call syntax. Unary operators get mixed up with infix operators. It's so much so that OCaml has special explicit operators to do negation. So it has like things like this: minus dot or minus, and then unary negation is it's like, what's it called, tilde negative. Yeah, that's how they do it, and it makes sense because this unary operator doesn't conflict with any binary operator. There's no ambiguity. Yeah, so here Haskell didn't sidestep this problem. The syntax is explicit here. It doesn't doesn't depend on white space. So a minus 10, it is called with a called with negative 10 is called with a minus 10. A called with negative 10 is a negative 10, because that's in parent. Yeah, so this doesn't have white space dependence, but what if it did, right? Negative 10 should mean negation, whilst negative space 10 should mean parser separately. That's what I'm eventually going to do. Yeah, so I'm going to put this in the description. If this is a VOD, I'm going to put this in the description of the VOD. I'll post it in here. Probably helpful to people. No, wow, I'm not even logged in. Okay. I don't even use Twitch logged in. So, yeah, I'll put this in the description of the VOD. So I explained function declarations. No, I explained mutable and immutable, do expressions, and function calls. That's all I did. That's all I did last between the stream and now. And now that I have variables, now that I have do blocks, now that I have function, like these function type decal thingies, these dash dash, so you can explicitly set them, I should probably start doing type checking now, right? I have the ability to do that. So let's just do it. So I'll just start, I don't know what I should name the file. Let's see. Or, let me check.c. Okay. Yeah, I don't know, so I think I did a little bit of reading, but this is all I have. So this is all I have to go off. This is the rules of the language. All types of variables are deduced at the initializer. So let's say v equals something. With this whole thing, you're able to determine a variable's type. They all have initializers. If not, it'll be explicit, right? But you can't just do this and then like can't just have v and then just like assign it later. No, the initial var decal node var decal, this thing here, you are able to deduce that type immediately. So the types of variables are deduced at the initializer. All variables have initializers, even undefined as an initializer. Yeah, so I want to follow in Zig's footsteps and see like A is an I32. If you want to initialize it later, you would do A equals undefined, and that's a complete proc node, like a proc decal. Not proc decal. It's a complete node var decal thingy. So it has to have this thing and this thing pair. So this will evaluate to just a probably a 0 equals, yeah, inside the IR. So this is this one statement. And then over here you can just do you can assign it to whatever you want. That's how things are gonna work. I'll do undefined in between streams after this one, but let's just do type checking now. And that also means type inference. So what a really complicated thing is the inference of function types. So I can do yeah, you can do this. Obviously, by looking at this, you can assume that x and y are probably numeric types, like integers or floats. But that's really all you have to go off. Let's say you have a equals x, y equals x called with y. How do you deduce the types then? So I think I'll do that in a different stream. Not even a different stream. I think I'll just do this in my own time, because that's actually just really hard. I'll have to read a couple papers. But other than that, I think I'll be able to deduce the type of something like v equals I32, v equals 40, and then v equals this thing. I'll be able to like find out, yeah, k is for sure in I32, or if this has no thingy, it'll automatically decay to an I32. Yeah, so I can be sure that k is an I32. That's what I end up. That's what I want to end up doing. Yeah, because you can see here, v0 equals 40. That's an inferred type. K equals 1 equals plus v0 or v50. Yeah, v0 and 50. So I want to be able to remove all these infer. I just want them to be their types. And what I can do first is that when I'm printing them, So go all the way down here. I want to attach the type before an expression. Kind of like this. Oh, where is it? Type debug string. Node dots. Yeah, all nodes have types. Like this. Okay, so yeah, you can see the types of these things. V equals infer, v0 equals, even integer literals are inferred because you can promote integer literals. They're just literals. Yeah, k equals infer equals, yeah. So the value of this isn't known yet. The value of v isn't known yet. The value of 50 isn't known yet, or the type isn't known yet. So let's begin. I'm gonna see what progress I can make with zero experience, not zero experience, zero prep, except for whatever you just read here. That's the rules that I have to go off. I have some minor. I wrote the type checker for the old compiler. Where is it? But that worked on a statement based. Where is it? Checker. Yeah, I didn't get very far. That's where I stopped. So let's start. Not key entry. All right. Start like p file, like C. I'll do because I have to check. Yeah, I'll do C. Check module 0. Yeah, where's p entry? Okay, and I'll just like C. Yeah, C module. Just check module. All right. That means I also need the checker context as well. Okay. How these things usually work is it takes an IR. I mean, how does it work in V? Yeah, so it returns a type T, and things like C expert, and it'll be like IR no T expert. This is how it works. So I think it takes an IR node expression. It assigns type to something and then returns the type. That's how V does it, and it's not that bad. It's not bad at all. This is the only way. Because I'm parsing recursively. I'm not doing any kind of special stuff. This is all recursive. There's a parsing context, there's a checking context. So C context. Okay. Yeah, and then this is C. C context C. Okay. And the checker doesn't work based on files, it works based on whole modules. So our mod T is mod, and mod per. Yeah. This is mod T pointer is mod per. Okay. Doesn't seem that hard. I just recurse over all of the expressions. Yeah, so just for. Okay, how did it work in the parser? In this language, everything is an expression, so I just need to do like void expers. Oh, even... Yeah, okay. Now I'm coming it from the perspective. I'm coming it from the coming from the perspective of this. So let me just write out the signatures. Top level takes in an ion node to expers. Yep. And then you'll end up with things like this. C. You wouldn't end up with like a C do. You'd end up with a. All right. Everything in this programming language has a type. So v equals 20, that's a declaration that evaluates the void. And then let's say v equals, not v equals 20. Yeah. And then v equals 50, that actually evaluates to a value that evaluates to 50. Because these are expressions. But this whole thing is a statement, but it's still an expression. It just evaluates to void. So if you have a bunch of expressions here, and these are all declarations, these really shouldn't evaluate to anything. But let's say you have this in a do block, you have to find out what do evaluates to, and what do evaluates to depends on the statements inside. So the last expression will obviously be the value of the do, right? But like it'll have to take the value here. So I think do needs its own special thing. Yeah, I think because then you end up with things like switch as well. Switch also needs a value, but that's different. That's completely different. I think I'll write something like C expers block, and then that returns a type. Then you also have to deal with these break expressions as well. So I'm gonna ignore that for now. I'm gonna go back to what we were doing with this. Yeah, v equals 20, k equals v plus 20. V plus v equals 40, k equals v plus 50. Yeah, that's what I end up doing. So C module, and that calls this C equals. What do I do in the parser? Okay, P equals C context, mod equals mod, what's it called? Mod P equals PTR. Mod. And that's all we need. That's basically all the context we need. See top level expers. It's being called with expers. Also, it needs a scope. That's probably the most important thing I left out. Scope T. S. Top level. Yeah, here's a top level scope. What's it called? Incompatible. Oh, it's the wrong way. There is your yeah. So C top level expressions. So this is just fill it in for me. No, I don't like how you do that. Equals 0. I is less than C. Plus plus. And STB. Okay. C expert. Is it pointer? It takes a pointer. Yeah, because you're changing it. Okay. Non-void function does not return a value. Okay, so let's pause it. Let's just do some stuff. Switch. Okay. That's the default. And what do we have? We have case infix. What is it? Let's see. So we have. You know, I draw a lot of parallels to this in the WebAssembly backend. Because here, let's say you have v equals I32 and v equals 40, right? You would parse up the chain and you'd hit 40, and you'd have to deduce its type. You already know down the chain that it's an I32, but you don't know up the chain. So what I could do is this. I could go pass type t, pass this type t up value or something. And if I was parsing v, I know it's an I32 immediately, and I parse its equals. I can push the up value to here, and you know that okay, it's got an up value. 40 doesn't have a type. Let's give it a type. That's how I did it with in the WebAssembly backend. So I could do that, but I think I'll try and roll with this for now. Yeah. Case node infix, because this is an infix expression. It's innocent. Actually, the first one we'll get is a var decal. But how do I parse that? How do I? I mean, what do we not have? var decal always evaluates to. It always evaluates to. Let me see. Yeah, so it's a left-hand side, which is a variable, and a right-hand side, which is an expression. It always evaluates to unit tuple, which is void. Yeah, so first I want to get the var. So what's it called? Let's do var ptr. Yeah, this is a nice macro to this style. Var equals the var decal left hand side. What's it say? Use one declared identifier p. Oh yeah, because it's C now. Yeah, so var always have a type. They always have types. If so, right now it doesn't have the type of this var here. When you get it from the lists of variables in the module, it currently doesn't have a type because it doesn't have one. It has a v equals I32. It doesn't have one. So I need to find out. I need to set it here in the variable as well. Also, what I want to do is I want to make explicit placeholders. So if I want I32 to return something that's inferred, it should be able to do that. And I think that's very possible. So I'm going to write infer syntax, because I wrote about this. This seems very possible. Yeah, so it infers the return type. Anyway, this doesn't have a type and we need to set it. So if var.type, let's type infer. We'll run cexpr on the right hand side, so just var. Okay, well, this line's good. So what are the rest? What are they giving me? Type mismatch. You know, it's not bad having a upvalue. This isn't even that bad. Type inference thing. If var type equals type infer, it'll infer it. Okay, and then if we know the type, it'll grab it. Okay, and then type equal is as simple as just doing this. So if these are just integers, the way my type system works. Just print diag with parse. Oh wait, hold on. Is Copilot reading my header file? No, I hope not. Error with pause. Yeah, type mismatch. Error. I want to write something for this. C. Type percent. A. B. And that's the location. All right. Sure. Error pause. Type dbg stir. Type mismatch. True. All right. C type percent. Yep. Fill it in. It seems good. Yeah, and the upvalue here is always type from the variable if we have one. So case node integer literal. Thanks. Case if upvalue equals type infer. This is like one of the simplest ways to write this. If it's type infer, that means expr. That means defaults is I32. To do bounds checking. Yeah, so it'll assume that all integer literals are I32, but however, if it's fucking huge, it'll raise an error. Yeah, balance checking. Is that spelled obviously? I hope it is. That's how you spell. Okay, I'm glad. Balance checking. Now just type infer return type by. Yep, and then expr.type equals 32. Else, you would probably, yeah, that means upvalue is right. That means I would want to like assert that the upvalue is like I would want to assert the upvalue is actually an integer. If it's like a struct, no. But I won't do that for now. I don't want to do C type assert. So upvalue. Upvalue. Sure. Unreachable. It was supposed to return. Yeah. Was it return? Return that unit. Draw unreachable. but I'll just do this for now. Still unreachable. I don't have a node type store. I'd rather just print out the enum. Oh, it's type, not kind. Look at my blinds. Glad I made the distinction. Remove the rest. Good. V is I32, because I inferred it. I mean, I didn't even have to write it. And V0 is I3240. Okay, that's great. That's 0. Yeah, so it assumes that. Or it assumes it. But let's say you write V explicitly to be a UA. Done. V is explicitly a UA. And the inference, like the upvalue inference, doesn't hold, because we know the type, it's not this. We know the type, it's not infer. We know it's U32, which means we get the right hand side type by passing the variable's upvalue into it, and that works. That's good. That seems good. Now, what can we do next? Now let's do also to do check that's upvalue is invalid integer type. However, we can or must that's simpler. So let's do node infix. So there's a left-hand side and a right-hand side. Now, integer promotion rules. That's the hardest thing. That's the hardest thing I was ever going to reach in the stream. Now, I'm just gonna like use V as a reference because they get this right. Where is it? What's it called? Primitive types. Here. So they get this right. There's an exception to the rule, which are, yeah, same type on both sides. A small primitive type on one side can automatically be promoted if it fits completely into the data range of the type on the other side. So if it's an I8, it can go to an I16. If it's an int, it can go to an I64. You can do all of those things, so... I don't know the best way to implement this. Probably some kind of not even a finite state machine. It'd probably be some like, not finite state machine. It'd probably be some kind of like jump table. Is this promotion possible? I'd also want to do things like also there's going to be things like this. Type V equals I32, and if you want to add a type V to an I32, you'd have to get the underlying numeric type. So I want to put that there as well. No, I don't want add. To do. Okay. It's 2 bars. No. C2 numeric. Or maybe not. That's probably what I want. To be strict and treat every type as a new type. Probably. But for now, I'm going to assume that the left side, hand side, and right hand side are integers. In fact, I can do that. There's an all.h. So I'll get C expert. S upvalue is type infer. Do we infer the... Do we use the upvalue? Yeah, I think so. Yep. Type T. Yeah. Now you see here, this makes sense. LHS type, yeah, let's do x plus y. The resultant type is always taking precedence from the left-hand side. As you can see here, the left-hand side is evaluated first using the up value, because that's eventually what it's going to equal to. And then we return the type. And then you would want to use the type of the left-hand side for the up value of y. Because think of this. Let's say you have this v equals 10 plus 50, right? You finish parsing the left-hand side, 10 as an I32. And you want to give that as an up value to 50, so you can eventually get 50 as an I32, right? So it parses like this, then you have 50, then the up value is an I32 because that's the type of the left-hand side, and it automatically coerces. And that's pretty good. That makes sense. That makes perfect sense. So I'll also have to resolve these things as well. So if LHS type equals RHS type, just return LHS type. Okay, else set not reached. We'll see what happens. Huh. We'll implement variables now. We need to implement variables. Case node var. Now all variables will be declared. All variables will be declared before they're used. So when we get to here, we already know the type of v. However, v may not even. However, the type of the node var, might still be type infer because it never knew the type of this originally, but now we know it, so we have to set it. So we can do this. What's it called? Expert.type equals var.type. We know this already. Okay. Wow, perfect. Well, that's still infer. I don't know why. Why is that still infer? Because expert equals LHS type. Wow, that's it. That's a completely sound program. So v equals 40, k equals v plus 50, and you can see here v0 equals 40. Oh, it's k1. I don't write the type of the variable here, but you can see it here. Yeah, k1 equals I32. That's the return value of this binary expression, and then it takes in two operands. So the left hand side is an I32 v here, and the right hand side is I32 50, and that makes sense. However, when you'll get to things like this, v equals v plus 50, you'd probably want to take the type of V and put it here. But that's for another day. And I'm not listening to fucking Blady. Blady. Yeah. Yeah, I'm gonna make that as a note as well. Inference. However, binary expressions are well defined for LHS. For I make wields here, intersection here. See what do. That's good. See, binary expressions are well defined for the left-hand side, so this weird exception, making a weird exception, probably won't fly later on. So let's see what other languages do. Anyway, V plus 50. Okay. So that's good. What did I miss out on? So let's do it. Let's do integer promotion rules. Let's do integer promotion rules. So let's do V a U8 and V plus 50. Let's see what it does. Okay, well that makes sense because V is plus 50. Okay, let's do what? Let's do this. A is 952. A equals 20. B is a U8. B equals 10. K equals A plus B. Okay, so not reached. So, let's do integer promotion. Do something like, do we need an upvalue? No, it's not upvalue. LHS and RHS. C. C infix promotion. Type equals I'll put this here. That's more unified. So, what else? I can just do return expert.type. This is nicer. Okay. C infix promotion. So, let's copy what V does, because that's a lot easier for us. And these rules are very sound, so I like them. Obviously, you'd want to find out what can I do. So these are all lined out like this: I8, I16, I32. This is what V does. Use as basic. So an I8 can go all the way up to these. This can promote to I size always. These can all promote to I size. These can all go up to I size, but never back down. What I don't want to do is write a huge... I mean, what can I do? I mean, I can abuse this. I can abuse this. I can write... let's let's just assume. Type integer start. And then it's end. Let's call it type. Yeah, type. So if whoa. If yeah, RHS. We'll do that for RHS. Left type, right type. If left type is greater than or equal to type signed integer start. Come on, complete it for me. Now does this make sense? Does this make sense? Yep. If right hand side type is less than that. If left hand side type, because left hand side always promotes. Return left type and else return right. That makes sense. Did this for integers as well? No, not integers. I want to introduce insane nesting as well. So let's try. Yeah, no, C2X extension, whatever. Return left type. You would want to promote left type and right type. You would want to promote them as well. Okay. Ret equals left type, and then you'd want to promote specifically the right type to the left type. Okay. Sure. Yeah, I love me my go-tos. Okay. And then we'll define these. Yep. Yep. Oh, it's actually U size and I size. Okay. You fucking... Yeah, I love kicking my camera. Sure. Now let's do the rest of this. So, yeah. It's based on integer. Integer order. Sure. Remember, it's an integer order. These are all the numeric types. So this is signed type to signed type. What is that? Throw that in. Thank you. I8 goes to this, goes to this, go to this, to this. And this goes all the way up. I can make this look a lot nicer. Yep, keep going. Yep, keep filling them in. All right. Left is assigned integer. Yeah. So left is right is assigned integer. CHATT underscore 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 says hi. Hello. Okay. So if the left hand side type is assigned integer and the right hand side type is assigned integer, that means you can promote them. Use of undercode level and why? Why is there an error? No. This goes all the way up the chain. Okay, and let me just refactor them to this. SI. Unassigned integer. Writing the compiler in C? Yes, I am. I'm writing a compiler in C as quickly as possible, and then I get the bootstrap compiler done, which is this one. And I write the compiler in its own language. And I can get out of C. Make things easier. Okay, so this promotes up the chain, and this promotes up the chain. Now what I want to do is promote where. Maybe I should define integer promotion rules on one hand side and then flip them. You know what? Okay, let me find out what V does. Let me do a source stat. V checker. Infix. Infix expression. Okay, this is a bunch of garbage. Ah, so it finds out the right type before the left type. No, it finds out the left type. Okay. I think languages usually choose high-level languages to write the pre-bootstrapping compiler. You're right. You're right. But then you end up with, well, if you consider C++ a high-level language, yeah, C++, Rust, whatever. I chose C because I like it. I like it, and it's not that hard. I'm not going to be really doing these like I'm not really going to be doing like sophisticated memory management in C. I'm leaking everything. I'm calling malloc and I'm leaking everything. I haven't bothered to write arena allocators, though I have written a couple arena allocators that are in use here. Uh, I'm just leaking everything. So I'm just writing it in C because I feel the most comfortable writing compilers in C because I've written a couple compilers in C before. Okay, so this left type. It's just a cost expression. I don't know how they do it. Do they have some kind of like table? What's the node op? Okay, this is an infix expression. Okay, if it's not equal, it does all this stuff. Oh, what is it? God, what? The last time I touched the V compiler was a long time ago. I remember how much of a mess it is. Okay, it does this. They match for things like this. They're very concrete integer promotion rules. Is relational. Yeah, plus minus mul div. Okay, unwrap generic on both sides. Yep, it's an alias. How did you learn low-level stuff, and how would you recommend one start learning it from chat? So, you mean to do with compilers? Because I'll explain from compilers. My first ever compiler was actually for a stack-based language, and that's incredibly simple. It's the simplest language you can do. It's just a stream of tokens, and you match on those tokens, and you just convert them into push and pop operations. I'll explain how I even knew what a compiler was. So, yeah, yes, assembly and how the computer works. So, yeah, yes and assembly, yeah, how the computer works. So, how the computer works. So, initially, when I was first learning programming, I learnt Python, and that was just to do some random stuff. But after a month, I had started learning C, and I only did C. I only did C for like a long time, like 6 months. I only did C. And when you only do C, you learn a lot of things about how it works. Then you eventually you start figuring out how pointers work, how the C code translates to assembly. And one of my most helpful resources is Compiler Explorer. So here you go to Godbot. I'm on like excessive dark mode, so you can't see my cursor, but you can see everything else. So yeah, if you look at this function, int square, int num, return int multiplied by num, you can see the assembly output right here. You can see it right here. And that's what like helped me learn assembly just off my knowledge of C. So and C compiled at like what's it called, no assembly optimizations. I mean, you can look at it. Each statement translates to the code needed. So let's do like a int c equals num plus 50, and then return num plus c. I mean, you can see that this statement here is the top, and then this here, this group of code here, int c equals num plus 50. You can tell. So it loads the variable from here, adds eax to 50, and stores the variable back. And then here it loads the two variables, adds them together, and returns them. You can easily tell just by looking at the C code and the assembly code, and you can work out these analogs in your head, and you can look at C and you can immediately tell what assembly code is generated. If you want to learn how computers work and how assembly works and how to write assembly, just learn C, and then open up Godbolt for a sec, like Godbolt, and just look, and just like you can even see like different optimization levels. You see here, this whole thing can be optimized into num plus 50. So you can see here, num plus 50. And I'll show you how I learnt compilers was what I said before. I created my own programming language. I'll bring it up. This is my first programming language. It's called Stas. Oh wow, didn't even time down. Here it is. I recently archived it. I wrote so this is Stas. This whole thing is Stas, and I have a bunch of blog posts about it as well. So this is the first programming language I wrote, and it took me a long time, but I learned how to write compilers. One of the best resources you'll ever have is not some book or not some paid course. I learned everything I needed to know on Wikipedia by reading code, by looking how other people did it, how reading blog posts, reading things like that. And you can even read mine. You can even read mine. So I wrote how, yeah, here. So this is my first introduction to C. You go all the way up. Here you start with creating a compiler part 1. I talk about tokenization, creating a compiler part 2. How does it work? This is compilers under the hood. This is my first compiler. It kind of sucked. Yeah, so this is tokenization. Compiler part 3. I did all of this. This is literal code generation. This is code generation that I did. So this takes when I got to here, I had tokens from the Lexa, and I converted it into this intermediate representation with some parser, and then I generated code based on that. Yeah, and it was like, so language conventions and type checking, Turing complete, and where is it? Creating a compiler finale. Your chat says your blog posts look very worth checking out. Thank you. I wrote these a long time ago. Yeah, I mean, seriously, if you want to learn compiler development, I've personally read papers, I've read blog posts, I've read Wikipedia, I've read everything online possible that there is. But what I haven't done is I haven't bought a book, I haven't bought a paid course. You can just find these things out on the internet. I've learned everything I ever needed to know on the internet. So my suggestion to you is, 1, learn C and just use C. Understand how pointers work and everything. And 2nd, find out how C transforms into assembly. And you can do that really easily by going on Compiler Explorer, godbolt.org. This is very important that you should look at. And then after that, you know how assembly works. You just look at assembly, tinker at it, and then now with that intuition of how statements and expressions transform into assembly code, you can write your own language. You can write your own set of rules, your own expressions, your own statements, and you can convert those into assembly. So it's just knowing C, right? Having that intuition of C to assembly gives you everything you need to know about compilers. That's everything I've got to say. So I'll go back here. So, I don't know how the fuck... okay, I'll look at it one more time. Where is it? Dot add. Where's the dot add? Some? Signed... There's unsigned right shift. Yeah, plus minus mul div mod zor amp pipe. Okay. How do they calculate promoted type? Chat says, I'll start with C then. Before, I thought I should start with assembly, then C. No way. No way. You learn C. Learn C. It's what everyone should learn. C is what everyone should learn. It should be mandated by state. You want to become a programmer, you learn C. Spend like a couple weeks learning it, and you'll thank yourself later. And you'll learn C, and then C has a very easy translation into assembly. So you just learn C, look at what it generates. You can learn. I learned most of my assembly off C, right? I wrote my first compilers off C. It's a really powerful thing if you know C. That's one of my best advice to you, to everyone. You do it. God, I feel sorry for the people who wrote the V compiler. Okay, not translated. Oh my fucking god. You'd think it'd handle the base case first. The V compiler transpiles to C, then compiles the C, right? Yeah, that's right. In its current state, it does. I'm currently the author of the V WebAssembly backend. That's what I did when I worked on the V compiler. Right now, I'm in the type checker. I'm familiar with the V code base. It's a compiler I've worked on. I know what's in it, so I'm just looking at it. Nice, thank you. You know what? Okay, fuck this. I'll do it myself. So this is unsigned type, signed type, unsigned type, unsigned type. So that's just this rank and this rank. You know, this doesn't look like that many rules. It's just 1, 2, 3, 4, 5. Okay, fine. I'll just do if left type, this type u8 and right type, this type. Is that I16? Yeah, I16. Okay, and left type should be I16. You know what? Maybe I shouldn't assign these. Yeah, I don't need to assign it. I only need to assign red, and then I can do some diffing. Let's say well this since perfect. Mine perfectly. Okay. Yeah, because they promote just the same. Okay. Okay, good. And that's this rank. And then I'll let Copilot fill it in. I know you got it. That's it. I8 goes to this way. U16. What about a U16? Did you not pay attention to that? U16. Yep. U16 goes to an I32. Right, if LT just type U32. Yep. Perfect. I32. Okay, so these are U32 to signed to unsigned and unsigned to signed. That seems right. Okay. And then I want to do integers to floats, so I can do this. Floats. Oh yeah, floats to floats as well. What about the other one? You would want to convert the left hand. Yeah, that's right. Okay, that makes sense. This plus this should always go to F64. Okay. And then you'd also want to do, yeah, integers to floats. So that's 1, 2, 3, 4. Okay, floats to integers. So, okay, the first one is an I32 to F32. So integers to floats. I32. What? Oh yeah, you know what? Thank you. I was gonna write 1 for 1 for 1, but that makes sense. Left type is an I32. No. The left type is an F32, and the right type is assigned. I don't know the ranges. A U32 is always yeah, a U32 can't go into an, well, I know a U64 can't go into an F32. No, a U64 can go into an F32. So residence type F32. And right type is less than or equal to type U32. A U32 can't go into an F32. A U64 can go into an F64. No, a U64 can't go into an F32. Yeah, and then the same is for the other side. Okay. Right type is an F32. Yep, and right type is less than. Okay. What else? What can go? So all of these. So this, I basically did the rank up to here. Yep. Mm. Right. A U can go. F32. It's better if I just wrote it as cans. So 32 can go. Okay, fill it in. Thank you. Left type is an F64. So this integers to floats. And a, what can an I32 do? An I32 has less. What's the range of an I64? Can an I64 F32 conversion of F32 to I64? Now, what about the other way around? Okay, this makes sense. I don't know what this guy's talking about, but what's before? Okay, think of that later. Okay, so an i32 can go to an yeah, e64 can go to an f64, so that makes sense. Can go into this, so just fill that in. Yep. Yeah, I love Copilot because it just does boilerplate for me. Good. So what did we do? We did all of this rank. All of this rank. We did conversions from this way to this way. We did conversions to this, and conversions to this, and also conversions to that. Well, okay. What about floats? Okay, we did floats to floats. Okay. Sure. That makes sense. God bless GoTo. Okay, now we need to figure out the diff things. If left type equals ret, do nothing. If right type is not equal to ret. It never happened. Okay, if left type isn't equal to ret, if right type is okay. Diff inserts explicit casts. What I could do what I could do is not evaluate the right hand side yet. And then use the type here. Makes sense. You'll see what I mean. Let's just hope I don't forget it. To do. Don't eval. Don't check. Evals left. So let's just hope everyone else does that too. The compilers. Alright, so what I like is explicit everything. So I want to write explicit casts if I end up casting the type. So what's my node cast? Is it cast? Node t dcast. Oh, alright. So if left type does not equal ret, that means the type of the left has changed. So that means pointed to LHS equals. Thank you. Oh, we have to do a dup as well. Do I have that in parser? mem dup. I want to share most of this code, so I'm going to put this here. Let's see. I'm going to share this. This isn't a very crazy function, but I'm just going to save it. mem dup. Okay. pointer. And type equals rat. Cool. And on the left-hand side, you know how to do the right-hand side. Thank you. Set explicit costs. Okay. Well, let's see if this works. I think we'll get an error though. Oh wow. Type get. IDX is less than type len. Then what is it? What am I returning? Oh no. Okay, see infix promotion. Ooh. There we are. That's undefined. That's really undefined what I just did. Okay. An A plus 20. U8 can be promoted, so why is that not working? Let me check. Yeah, okay. I'm not writing a chain all the way up because it only works for U8 to U16, but not U8 to U32, which means I need to redo it the way I did this. So I think that's better. RT is... R is a sign type, and write type is... Is it less than? Greater than or equal to a type UI16? Okay. Let's just say. Okay. Left type is type U8, and well, yeah, and sign type is this. Okay, now fill in the rest for me. Sign type is type U8. How could I do this in like a stepped form? Yeah, let me steal these. I need to do these in a stepped form. I think I can just do addition with the pointer. Okay. Actually, I can think of it like this. If... No, Copilot. If the left-hand side is a unsigned type, and right-hand side is a signed type, do this. So if right type is this is better expressed as a while loop. It's probably a lot easier if I express it as a while loop and just continue pausing. But that's no fun. So I'll finish this. It'll be some kind of stepping. And yeah, if it's ends right type is greater than do type equal to no, because you already know it's within bounds. It's less than type U64 because that can't go into any sign type. So anything between U8 and U32 can always go to the next up sign type. Which means no, because I don't want to do that. Let me just do div equals. Yeah, this is how you do it. Right type, because the right type is a U64 minus sign integer start. That means ret. Let me see. Sign integer start. That doesn't make sense, because the right type you know is a U32. You'd want to do. Yep. And then that means you'd want to add 1. Yep, ret equals LT plus diff. Let's just hope that works. I mean, I hope that works. And then what you'd want to do is the inverse of that. Now, does that work? Okay, let's just see. Let's see. Wow. Didn't even work. Oh, because didn't go to. Oh, it will promote it all the way up to U size. We'll fix this bug first, though. I don't have a cast expressions yet, so let me just do that. Node d cast and node. Yeah, there's no need for that. Okay. What does cast look like? So, k is a U size. K equals the value of that is a U size. So U size cast an I32 and add a U8B1. A U8B. But wouldn't you want to be casting the other one? Alright. Let me see. Let's see what the checker does. Yeah, so ret equals so left hand side is an unsigned type. Wait. I'm sorry, critical thinking takes my brain a long time. Left side is an unsigned type. And the right hand side is a signed type. You'd obviously want to calculate. No, it's literally this. Right equals right type, and then left type. As long as left type is less than that. Okay, I don't know why I needed this diff, because I'm not supposed to be doing that. Good. Oh god, that worked. Yeah, so k is an I32. K equals yeah, so it adds A, which is an I32, to B, which is a U8, but you cast the U8 to an I32. Let me remove the type hints though. Yep, still the same. Remove the type hint there. And what's the casting like? Still an I32. No need for casting. Isn't that great? That works. So let's test the rest of this. So that works. Let me just make a commit. What stream is this? This is stream 5. checker string 5. Initial type check plus infix promotion. So this is integer promotion. All right, let's do some testing. So we have A and B, and let's say let's promote. Let's see what we can do. Let's add an I8 in the F32. I don't know what it'll do. Let's hope it does something. Okay, it does something. I8, F32, K is in F32, that's right. In F32, cast I8. That's good. But what can't go in an I32 and in F32? An I32 can't. Or can it? Can an I32 go into an... Okay, that works. Okay, no, I was right. But an I64 can't. Or it can. Okay. Well, an I64 should not be able to go to an F32. Let's see. So the left type is an F32. And the right type is... No, so okay, so the what's it, the left type? Okay, left type. Okay, the right type is an F32, and the left type is signed, and its type is less than I32. Okay. So it should work. I mean, I don't know why it's not, why it's, it should raise something, it should raise an error. What does it cast to? It casts an I64 to an F32. And RT is less than or equal to type I32. Type I32 is less than I64. I don't know why that's happening. I'm checking this in my head. Oh wow, we're up to 2 hours on the stream. Oh my fucking god. Usually I keep streams under an hour. Under an hour and 30. Fuck. Okay. Alright. I think I'll call it here then. I'll call it here. I'm done for tonight. This is good though. This is good. I'm pretty sure I think I showed everyone how this all works. I mean, it makes a lot of sense. Basically, you start at the root, you pass the left-hand side, the right-hand side, you converge them. If the types mismatch due to integer promotion rules, you write explicit casts in to make things all concrete and nice. And like here, var declarations, that makes sense. Like explicit here, if it's without it, it's an inferred, and it's inferred by its initializer. Things like that. Variables, that works. Integer literals takes in the upvalue. I think this is a pretty good stream. What else do I have next? What do I have in store? So I'm going to implement. This is a nice stream for now, right? I showed everyone the fundamentals. Then I can implement all the annoying stuff, like everything I have here. So like do block stuff, like decal syntax. No, I did that. Yeah. Yeah, like I have to do other expressions, but once I get the AST type checker, I can start generating assembly code. I can start generating another form of intermediate representation. I think the last thing I need to do before I do that is closures, because I'm adding closures to this language. It's a functional language. But other than that, I'm gonna go now. Good stream.